Hello and good morning, everybody. Welcome to another Land Effects webinar. We have a special guest presenter today for you guys. Ron with Amiad Water System has graciously accepted to present another webinar for us today. This one's on Intro to Filtration and Technology. So if that's what you're here to see, you are in the right spot. We've previously actually had Amiad do some guest presentations for us, including improving water quality by mechanical filtration and filter selection and sizing guidelines. So we're just sort of carrying on this little series about proper specifications, when and how and where and what and who and all those kind of questions for your filtration guideline needs. So we're really excited to learn more about that. Just a few house cleaning items before we get started. This is being recorded, so welcome to those watching in the future. And if you want to recap or rewatch anything afterwards, we are going to be posting this on our website, so definitely go check it out there. This is live right now, so please open that Q&A and chat window right now so that you can kind of be prepped and ready to go for any questions that you guys might have as Ron goes over things. Try and ask those questions in the Q&A box. Use that chat for any other banter that you guys want to do back and forth. And if you're stuck in full screen mode, there should be a view options up at the top that can get you out of there so you can move that dialog window around. So without any further ado, I'm going to turn this right over to Ron and take it away.
Awesome. Thank you, Jake. I really appreciate this opportunity to be able to share with you about filtration and the joys of filtration selection in the landscape irrigation. So what I want to do is I'll introduce myself a little bit. I'm Ron Krause. I've been kind of around the landscape world for a lot of years, and I am with Amiad Water Systems. I run the landscape greenhouse nationwide, so I have a little bit of responsibility in terms of what I deal with. I come from Amiad. Amiad Water Systems it's been a world leader in the water treatment and filtration solutions. We not only work in the landscape world, we work in the ag world as well as the industrial and in the water treatment side of the world, or filtration. We have, over 700 employees worldwide, and we were established in 1962. So we've been around filtration for a long time. What I want to do is get into some of the meat and potatoes of what we're going to talk about today and how we want to function in filter selection in the landscape irrigation world. In order to select the proper filter for your project, we're really looking at 5 basic but very important questions that we need to ask ourselves when we start designing or specifying filtration. The first one is water source. The second is flow rate, your gallons per minute. Third is your operating pressure or your static or dynamic pressure. Fourth is required filtration, like your manufacturer's requirements or recommendations or things like that. And then fifth is maintenance. One of the telltale signs that we always deal with in terms of designing a project is the maintenance, the long-term plan. So let's start out with water source. Let's talk a little bit about the water source that we're going to put on our property. Some of us have the options and some of us are kind of just dictated to what we're given. But if you do have the options, these are some of the available water sources that you may see throughout the nation. Municipal water, your potable water. You'll have surface water, well water, gray water, rain or storm water. Recycled water is another one that you'll see frequently that's becoming more and more popular. The reason why we bring up water source is we really need to understand how dirty the water is. This can be done by a simple test, TSS, or a total suspended solids. So we want to understand how many particulates are in the water that we're dealing with. What I've done is I created a slide that gives you kind of a breakdown of some of the stuff that you'll see out there, and maybe give you a basic idea of what our interpretations is of these waters and how good they are or poor they are. Municipal water, it's a great water. Obviously, it's treated and given to us clean so that we can drink it. I will say that it still has some very small particulates in it that need to be filtered, probably more for micro irrigation, but it is still required. Obviously, that water is getting more and more expensive as we continue down the road of droughts and conservation. Your surface waters are your pond, your lakes, your surface aquifers, and your canals. That can be kind of poor water. Unfortunately, it's not going to be given to you clean, and you're going to be required to do some filtration in order for it to function on your site. Well water is really popular. This has been one that we've seen a lot of activity on, especially for filtration lately, because one of the issues that we're running into is the aquifers amount of water that's in them is deteriorating, and they're starting to pull more debris and sands and silts out of those aquifers. So we put this one down as can be good to average. Your gray water is your reuse from your discharge of your property. So for example, if you're pumping, if you got water that you're using and your dishwasher is pumping water out, a lot of times they have a reuse option that you can do. This water obviously is pretty dirty and is going to require a lot more specific filter in order, and other than what's off the shelf. You might see some sands, silts, organics, hairs, fibers, and things like that within those that water. Rainwater is another one that we talked about in the past. This one's becoming more and more popular through state mandates that's requiring us to collect all of our rainwater on site and reuse it. The initial setup can be very expensive, but obviously there's a return on investment. In the long run, it's a lot cheaper to manage your own water on your own site. Again, your filtration, you're going to see sand, silts, and that's a pretty dirty water. Recycled water, it just ranges depending upon what district you're a part of. To be perfectly honest, there's some districts that actually have pretty clean recycled water that's distributed, and then some that's pretty dirty, and they run into challenges as they go. So again, we put a poor to average rating on that water. And these are our guesstimations on this water. It's important that if you're getting into detailed design requirements and things like that, as we talk, we'll go over those requirements that you're going to see. It's important for you to take the time to understand what's in the water before you really put a specification out there for a particular filter to be used. I show this slide because I want it to be understood what TSS is. As you can see on the left, it's a high percentage of TSS. There's a lot of particulates in there. And what they do in a TSS analysis is they'll give you basically a percentage of what is each particulate size. So they'll give you a percentage of how many particulates are in the 100 micron, how many are in the 80 micron, in order for you to be able to determine what the best way is to filter your system down. Your low percentage TSS, obviously on the right, I just showed that so you have a comparison there. So next, as we're moving along, we're talking about flow rate, gallons per minute. You know, this comes down to your system flow rate, what's available at the site, what line size you have coming in, what you can use, and what is what your flow rates are based on what the city is going to give you or what you're pumping off your system. And then you need to determine what your design flow rate is. This can be as simple as basically taking your how many valves, your valve flow rate on it, and then how many valves you're going to run at any given time so that you can determine what that is in gallons per minute. The reason why this is important for us in terms of flow rate is all filters are designed based on a max and a minimum flow rate. And then with comparison to how dirty the water is would tell us how much we can manage in that filter and what it will do for us in the long run. So flow rate's an important phase of understanding what sized filter we want to put in. Obviously, this picture of a Filtomat is a massive amount of water moving through this system. So it required a fairly large filtration system to be able to manage that. Next up, we have our static and dynamic pressure. The reason why it's important for us to understand static and dynamic pressure or our operating pressure is that we want to know static-wise, when the system's off and not running, what's our max pressure at? What's it going to be at so that our filter can still manage and maintain that pressure? It's important for us to understand the dynamic pressure as well, because when we do have that, we understand that there is a variable between the two. Usually dynamic pressure is a little less, but a filter is designed based on what it can handle max pressure and then what it can handle minimum pressure in order to flush properly or to clean properly. So having that information is important. If you can't get dynamic, at least get us a static or at least understand your static pressure, then you can make the decision accordingly and move forward without having to stress over those issues. All manufacturers have a required filtration degree on their product. And as we know, filtration is a separation of solids from water. Any particles larger than a certain size need to be removed to protect the irrigation system emission devices downstream. And usually in the landscape, we see anywhere from 80 to 500 micron. Those are some of the various filtrations used in landscape. Micron is a more accurate way to measure filtration in degree, and mesh is the most common term used. We use mesh a lot in the landscape world. And most manufacturers have a recommended filtration requirement for their product, as I mentioned. They need to have it to a certain point so that that emission device will work properly. I do want to do a little review here on what is a micron. If you know this, you can close your eyes for a second. If you don't, then listen up. What is a micron? A micron just describes a 3D diameter size of particle. If you look to that chart on the left, it shows you a 70 micron. That's about the diameter of a human hair. So a micron, it gives a pretty distinct measurement. And anything under 40 micron, you can't see with the human eye. This chart right here is kind of a comparison chart between micron and mesh. Obviously, they go opposite of each other because mesh is basically how many wires are within a 1-inch screen area. And this definition is actually taken from the garment industry. Micron, on the other hand, is actually the measurement of how big of a particle can fit through that diameter sized hole. So micron is usually more accurate and gives you a little bit cleaner definition of what's available to go through your filter. So now back to our required filtration from our manufacturers. Every manufacturer has a range or a filtration range required for their product. So if you look over on the left, these are actually specifications in cut sheets on some particular product out there. And if you look down on the top one under operating range, your required filtration is 150 to 200 mesh or 75 to 100 micron. That's actually a pretty small filtration requirement for this product. If you go down one, this one only gives the minimum filtration requirement in mesh. So that's why I was wanted to show you the chart from before, because 120 mesh is about 130 micron. And every manufacturer's operating range varies a little bit. So like drip emitters, you'll see anywhere from 100 to 130 micron. Your precision sprays, your rotator nozzles, things like that are a little higher efficiency nozzles. Those average around 200 micron. And then your standard spray nozzles around 300 micron, just to give you an idea. So increasing your filter size can cause potential issues for your devices downstream. And I put this in here because a lot of times what we see in the world of landscape is that we'll put in a filter, or they'll have a filter on site, and the filter tends to clog up more frequently than they like to clean it. And so what they'll do is they'll put in, let's say it's 100 micron that they have in there. They'll take and put in a 200 micron in order to ease the burden on the filter, meaning that they're going to allow more particulates through so that they don't have to clean the filter as often. The challenge with that is that, as you and I know, what we just talked about, that filter is now going to allow those particulates to fly through. And if you have a certain required filtration on your requirement on your emission device, where does that particulate end up? It'll typically end up within your emission device and clog it or cause pressure issues. And this could be a severe effect on your distribution uniformity. And so I've done some calculations and some different things on what I've done with my water conservation side of my brain. For every 10% you decrease your distribution uniformity, it's calculated about in a 30% wasted water. So something to really consider when we put in a filter in what we want and what we see being done for our filters down the road. Which kind of brings us to our next step, which is maintenance. Again, it's something we don't typically control on our side when we're designing things, but we have to think about how this property or project is going to be maintained down the road. Number one thing I always think about is accessibility. So in tough locations, it may dictate the type of filter that we need. If it's hard to get to, challenging to work on, and or clean, it's definitely something to consider when you're putting in a filter that is going to need to be manually cleaned every so often, obviously. The next thing is service time. So how often is someone going to be available to clean this filter? Is it a weekly maintenance? It is a daily maintenance? It is a monthly maintenance? If the filter is dirty, it dictates the maintenance schedule. And so it's something to consider when we're designing and putting these things together. We also go back to our water source and our flow. You know, how much water are how dirty is the water are we putting through this system? And if it's pretty dirty, then we really obviously need to consider what our filter is and what we have on the system. Efficiency issues, you know, we have to increase our cleaning times if we want to have our system functioning properly. So it's really important for us to think about that and what we're doing with our design requirements here. Downtime for cleaning. When you're dealing with manual filters, which we'll talk about later on in this presentation, is that your system has to be shut down in order to clean. And if that's the case, then you have to consider that. Can the system maintain being shut down for a period of time? And if not, then it's obviously something you really have to consider when it comes to filtration and what style of filter to put in. Obviously, your flow and pressure is dictated by a filter. So if your filter is clogged and dirty, your pressure is going to be affected and your flow is going to be affected, which will affect your downstream system. funding for maintenance, if there's just not funding to maintain a property or the site, that's really critical to think about when it comes to maintenance on the filter. Limited labor funding, and then again, going back to the water efficiency issues, we just definitely have to be thoughtful of that. So maintenance is a big part of the key elements that we have to decide and use as part of our filtration selection process. So I want to kind of explain the three various ways that filters function so that we can kind of understand why the maintenance and why those things that I talked about are important. Number one, we have what's called the manual filter or a manually cleaned filter. This filter has to be removed. The element has to be pulled out and scrubbed and cleaned in order to clean the filter properly. Most of our 3/4 inch to 1 inch filters are like this in the industry. Next, we have the backflush or reverse water flow through the filter, dislodging and washing out particulate. This is what I call the indirect backflush. You know, if you have a valve on the bottom of the filter, that's a great valve to have. It can be opened up and allow water to flow and get the majority of the, bigger particulates and things like that that are on the inside of the screen. Not a bad option for cleaning, but it doesn't clean the filter totally properly and as good as it could. And then we talk about our focused backflush. This is where you reverse the water flow through nozzles and you concentrate that cleaning to less than 1 square inch, which increases the suction force. So it's kind of like, taking a blower to your house to clean it, as opposed to vacuuming every inch and cleaning up properly. So, obviously it's a better clean. So each one of these has their place in our world, but how we use them is important. So I'm going to spend just a minute here on the pros and cons of each different filter type: the manual, the backflush, and the focus backflush. So manual filters, you have some specific pros and then some cons to it. The pros are they're a low-cost option. They're pretty inexpensive to install, and their installation is simple, and their maintenance is pretty easy, other than you got to pull them apart and clean them. Some manufacturers, they have a stainless steel screen, which is important. And then some are typically like a propylene housing for corrosion resistance. These are typical sizes, are anywhere from 3/4 inch all the way up to 3 inch. The cons are is it is time consuming to manually clean them. You do have to shut the system off, and they do require constant supervision. So you actually, in order to know they're clogged, you have to open them up to look at them. So the Amiad tagline is one of those filters that we're talking about. This filter is a stainless steel. It does have a propylene housing. It's great for landscape applications, 3/4 inch to 3 inch. It's rated for 116 PSI. That's important for you to remember. It's a low cost option. That's a great filter for your, where you can actually do your simple cleaning. I put this slide in here because I really want to make sure, we understand what the 2x4 rule is. The 2x4 rule is not something that builds your house, right? It's a great rule to understand in the filter world. So when the rule is, when you double the surface area of the filter element, you quadruple the time between cleaning. So we're going to kind of go through this real quick. So if we take the tagline screen filter, the 1 inch, and we go down to that bottom chart where it says 1 inch, the tagline screen filter, if we were to cut it down one side and roll it out and measure the square inches of that, it's 17 square inches, right? Okay, everybody goes, cool, that's great. That's big. And then you take the other one and you cut it and you measure it, it's 7 square inches. All right, well, it's smaller, it's more compact, it fits in a smaller space. Here's where this becomes a benefit to have the larger screen area. Obviously, you can see it's about 250% larger. This translates into 6 times less cleaning. So if you're cleaning every month, you're now taking that down 6 times less if you have a larger screen element. Okay, so that's an important thing to think about when you're sizing your filter. Even if you go manual filter, that's important to think about how often that's going to flush and clean. All right, so now the Amiad manual black plastic filter. This is another one of our plastic filters that is anywhere from 3/4 inch to 3 inch. It has a stainless steel screen, the propylene housing, and it's rated to 150 PSI. That's why I was mentioned about the whole 116 PSI. This is important to remember. There are 2 different ratings on their PSI of what they will manage max pressure. And this one's available in screen or disc. So let's talk about the pros and cons of a semi-automatic filter, which is it's a reverse backflush, which has that focus backflush, but it's done manually still. The benefit is you still don't have to take it apart. So it's a low-cost option, simple installation. And again, the stainless steel screen is important. We don't want rust and corrosion. Propylene housing or steel housing usually comes into sizes 2 to 8 inch. The clogging indicator is on this one, which is a great feature to have so that you can walk up and see whether it's actually clogged or not. And not all manufacturers have that, but some do. It can be cleaned without interrupting your irrigation cycle. So that's important to think about. You know, we don't have to shut down the system in order to clean this filter. It is a low pressure requirement for proper cleaning. Some of the cons are it does require constant supervision. You do need to check this filter and make sure it's not clogged on a regular basis, depending upon how dirty your water is. So it does require the presence of an operator to clean as well. You can't just, it doesn't do it automatically for you. So Amiad has a semi-automatic filter that comes in sizes 2 to 3 in plastic housing and 2 to 8 in steel housing. It has stainless steel screen. It's usually good for small ag and landscape applications. It does have a clogging indicator on all of our semi-automatics, and it can be cleaned without interrupting the cycle, and it requires less than 35 PSI. So we're going to talk about self-cleaning and how that works. And I have this sample here of the Mini Sigma, just so we can walk through the parts and functionality of it. We're going to start on the bottom left, and then we're going to go through 1 through 6 and talk a little bit about 7. So if you notice, number 1, it looks like a little coarse screen over on the left. And that's exactly what that is it allows, it's an out versus in flow. So it comes on the outside of that screen to the inside of that screen, which all the debris and larger particulates attach to the outside. And then it flows to the inside of the fine screen, which is number 2. When it gets on the inside of that, then it flows to the outside of that and goes out the outlet. That's important because understanding the flow allows you to understand how the cleaning process works. If you look at number 3, which is down on the bottom right towards the front of that filter, it has a hydraulic turbine. That turbine, when activated, will hydraulically spin the number 4, which is our suction scanner shaft. So the white suction scanner shaft that goes the length of the filter element. The number 5 suction scanner nozzles are what move and go circular around. And they are what sucks the debris off of that screen into the shaft and then out the discharge or flush valve, which is number 6. So when the flush valve opens up, the water flows through there, out the discharge, sucking off the dirt and debris off the screen. And as it's turning, it moves up this filter. So it's cleaning the entire filter area. The ADIP, or controller, which all automatic filters have a controller, whether they're set by timed or set by pressure differential, is what determines when this flushes. So no different than your irrigation timer. It may have a set time to flush, or it may have a pressure differential read that sets it into a flush. The pressure differential read means that it reads a bearing on the inlet pressure to the outlet pressure. And when it measures that, it's measuring it usually about 7 psi, which is what most of our automatic filters are set at. We'll send it into a flush cycle once it reaches that. So if the inlet is 100 and the outlet is 93, it will automatically send it into a flush cycle, cleaning the screen, allowing it to have free flow. So let's talk about the pros and cons to an automatic filter. So some of the pros, it can be cleaned without interrupting the irrigation cycle. So you don't have to turn off the cycle for this to clean. Again, the 316L stainless steel. The automatics come in a propylene or steel housing, typically 2 to 20 inches. I mean, 20 inches is a large filter, but typically in those ranges, you can get them. Fully automated and optimized cleaning processes we just talked about. Their consistent performance of the irrigation system. So the 7 psi is important because that's typically, if you go below 7 psi, your system downstream is going to struggle. But that's why that keeps it consistent with the automatic filter, because it flushes and allows the water to keep flowing freely and at the same psi that you need and what you designed to. Some manufacturers offer the electronic and/or wireless control with added HMI features. And then again, a flexibility of installation with automatic filters. Some of the cons, obviously the product requires a little higher minimum pressure to sustain cleaning cycle. And then some require a little longer flushing period, which is more rejected water. And then obviously cost is a factor in there as well. Amiad has a series that we've seen used in the landscape quite frequently, is the Sigma series. This does have the stainless steel. It is good for good to poor water quality, small to medium ag and landscape. The Mini Sigma series comes in a 2-inch NPT threaded or 3 or 4 flange. And then the Sigma Pro, which is the big one on the left, that one comes in a 6 or 8-inch flange. All of these have the ADIP controller, which is a Bluetooth-enabled controller that operates on a pressure differential that will flush your system when it reaches that 7 psi differential. Again, they can be cleaned without interrupting the cycle, and they require 22 psi for proper cleaning. So that's your minimum pressure. So that's why we talk about the minimum and maximums of the pressures. There is 2 versions on the Mini Sigma. It's online or angle. Here's some pictures of these installed in some different projects in landscape. And the Amiad Mini Sigma fits a lot of the landscape projects really well. So let's go back and review a little bit. So what's our best filter for my application? When we think about our water source, our flow rate, our operating pressure, our required filtration, and our maintenance, this is where we have to think about those items, as well as the what to use, like what filter, the manual, the semi-automatic, or the automatic. If your water quality is not terrible and you're not going to be cleaning that filter that often, a manual filter is a good option, and it will be a good fit for the bill because it's inexpensive and easy to use. If they have time to clean it, again, this is where the maintenance comes in. Where the semi-automatic filter falls in, if the water is just too dirty and it's requiring super amounts of cleaning and the process is overwhelming, it's a consideration to look at the semi-automatic, because there'll still be a maintenance on site and still be able to check the indicator and make sure it's flushing properly, and then they can do their job accordingly. Again, location and accessibility is important. The automatic filter, this is when the semi-automatic filter is just not keeping up, and the water quality is pretty bad, and we're continually cleaning and working to keep this system in operation properly. It's something to consider, to look at. And also with all that, you have to consider the return on investment. It might be a little more expensive up front, but in the long run, it's going to give you a better setting and a better system for the long run. So again, that's why we have to understand the 5 main questions. Again, water source, your flow rate, your operating pressure, your required filtration, and then your maintenance, what you're going to end up with down the road. So here's some examples of installations for the manual and the semi-automatic filters. On the left, that's a semi-automatic filter that's installed. And basically, like, in order to clean that, it's like rolling down the window on the old classics cars. You got to open up that valve down on that bottom, the ball valve, and you crank that crank up, and then you crank it back down, and it will do exactly what the fully automatic does, where the scanner sucks off the debris off the screen and allows it to flush out. The other 3 on the right are manual filters. These ones you would have to pull apart. You take that big D-ring off and pull that filter apart and clean it. You could intermittently clean it by opening the bottom valve, but as you know, that's that indirect flush that I was talking about. It will clean it okay, but not perfectly. The real true way to clean these is to pull it apart and clean it. You got to shut the system down to do that. So I want to give you a couple applications here in reference to some projects that have filtration on them and how they look, and some ideas of how the installation guidelines are. This application is a landscape irrigation for a city park. You guys may remember this if you were on last time I shared it. This one had some average water. It was a pressurized surface irrigation. This one ran 400 gallons per minute at 80 PSI. So it's a lot of water moving through this thing. Had a 200 micron screen, and it improved the water quality, but it's a fully automatic filter. This is the big brother to the Mini Sigma. It does the exact same thing internally that the Mini Sigma does by being a fully automatic filter. This is the filter mat in a bell housing, which is a little bit more compact, still handles a pretty good amount of water. And this one again is a city park that has surface water, or pressurized irrigation water, I should say. And they were constantly having to clean the filter that they had there, which was manually. So putting in a fully automatic for them was a great option and saved them a lot of time and effort. So here we have the Canyon School District. They have the similar kind of application, but a little smaller gallons per minute, 275 gallons per minute and 90 PSI. They had average to good water. They only needed to filter down to 90 or to 300 micron. So they were probably using rotors or larger sprays in order to irrigate their system. So their manufacturer's requirements were a little different in that they were the 300 micron and not the smaller, like the 120, 130 that we were seeing on the drip back earlier. This is another one, a landscape city park that has the filter mat. It's a 300 gallon per minute. And it is again, an average water, but their manufacturer requirements were 200 micron. So probably spray heads or even maybe some rotating nozzles out there. And this helped them keep their system in check and allowed them to run the flow and the water that they required and needed. So all these are good examples of basically the aftermath of what they've done and following the requirements based on those 5 questions that we ask. Again, 5 questions we asked were water source, flow rate, operating pressure, required filtration or the emission devices required filtration, and then maintenance on those things. So, well, that's about all I have to share. I mean, we got a little time for some questions and answers and things that we could come up with, but I appreciate the opportunity and the time to share this with you guys.
Great, thank you. Reminder for those watching, if you have any other questions, please get those sent in while we go over these few that we've already handled. Piero was actually able to handle a couple, one specifically, which I think we kind of knew this was going to happen, but asking if there was a video showing that filtration system working, which we sent the link to the video so you can watch it. I'll actually make sure to post the link in the recording as well so that you guys can have a deeper look into how that actually functions and stuff like that. Another question, there were those pictures with a few of those sort of auto scanning and then the manual filters in the landscape. Are there any specs or I guess regulations on how close those filters are to be placed down at the ground? Trying to get those things off, is it supposed to be on a pad? Can you give any insight on installation wise?
Yeah, there's really no specific requirement other than there does need to be an atmospheric break on the flush, which usually makes it a little easier for that to flow freely. But in terms of height, it's more accessibility for maintenance and long-term plan for that system. On the manual ones that we were talking about, the manuals and the semi-automatics, it's more of an accessibility to be able to take the screen out. It would need some clearance below it. Having a pad is always the best, obviously, because it gives us the guaranteed clearance based on what that spec might be. And each filter will vary a little in different in that length. We do have some great details on the LandFX site that shares exactly those details and that dimension that is required for that.
Perfect. Steve Cook has a great question. Where does the flush water go? Basically talking about those pictures, the gravel with a concrete collar install detail is a great one. Do you do a pipe to a gravel, that kind of thing? I know you talked about the air gap side of things, but yeah, that we don't want to call it wasted water, but the shed water. What would you say to that?
Yep, great question. Every water is going to be a little different requirement. Like recycled water has a specific requirement for it to be discharged not into the open, because they want to ensure that there's protection based on water quality and all those different state mandates that they may have across the country. But what we have done is created exactly what you're saying there, Steve, is a detail that goes along the lines of an atmospheric break into a larger collared pipe that will go into the ground and into a seepage pit or a gravel pit that is related to that. So that's typically how we would do it. Not all designs and systems are installed like that, but our recommendations is always to discharge into a larger diameter pipe than what's on the filter itself. So if the filter itself is 1.5 inches, always upsize or keep it the same as, don't downsize, because that restricts the flow. And then what we do is we atmospherically break that into a larger diameter pipe into the ground. And you can do that by, that pipe can even go down inside of that larger collar, which is still considered an atmospheric, because it's got the free flow to go into that collar.
Great. So I had a little, I guess, 2 cents to chime in as you were talking about the the max allowed pressure on the filter and the screen and stuff like that, keeping that in mind. And then combining that with maintenance. I used to work out in the field and repaired all kinds of stuff. And what I saw from an improper either disc size or screen size, or compared to the water quality, crushed those screens pretty darn quick. And so, just stressing the importance of always making sure those screens are cleaned, because not only does it affect that pressure and the system itself, but just completely destroys the inner workings of those filters in general. So just wanted to reiterate that.
Very good point. Very good point.
Tanner asks, how does the automatic flush for the auto filters work when the filter is enclosed in a box?
Great question. What we see a lot of, and I'll just give you some examples, and I'm not sure what kind of box. I'm going to probably answer two different ways. One is we'll put them in enclosed boxes all the time above ground, where they're in a pump manufacturer's enclosed site or part of a pump manufacturer's design. And they'll take that discharge pipe and exit it out of the enclosed box and put it into that collar, or they'll put the collar, like we talked about, in the pump housing itself and into the concrete basin below. The only challenge with that is you want to make sure that seepage pit is large enough to handle the amount of backflush that you may have. Some of these filters we were showing, the Mini Sigma and such, will actually flush probably anywhere from 4 to 5 gallons each time it flushes. So it's not a ton. Now I'll go back and answer, if you were to put this in an enclosed box underground, it's not we don't recommend to install them like that, because they're a little larger than most of the boxes that you're going to get out there, even in the jumbo size. It is possible to do that. You just want to make sure that it's going to not get obviously saturated with water, because the controllers are not as concealed as what you might find out there in the world that we have with, like, the Hunter hockey pucks and things like that. I would recommend, if you were to do that, to carefully consider a few options. The one is, it's got to have an atmospheric flow for that backflush. And then two, it's got to be accessible to work on. If you can't access the filter and do service on it, because even though it's a fully automatic filter, it's going to require some servicing and some maintenance maybe annually or twice annually, to make sure that it's functioning properly. So that would be my thoughts. I hope I answered that.
Yeah, he did clarify too.
Oh,
an
okay.
Anti-vandal box.
Yep.
Specifically. Yep. So
we actually have those designed into exactly what you're talking about, because we look at the backflow market and what's been done in that market and what's happened to backflows without having with having them stolen or damaged. And so there are specific boxes and anti-vandals that will fit. And then we usually have those flush valves go right down into a collar into the concrete.
Cool. Well, you know what? I think the questions have slowed down. 10 minutes to 11 here. So I want to say we should just give it an ending point and say thank you guys. Oh, wait, sorry, Steve. You just got one last question. We'll throw it in here just because we love you. So he's just sort of chiming in, saying the 4 gallons to 5 gallons is a decent amount. So it's good to know that the sump can be sized properly. So
yep.
Yeah, just making sure that detail is definitely clear, that that's what it's got to do for sure.
Yep, exactly. So, and again, like I said, the recycled water requirements have a little bit different view on that, but they still will allow it to be based on a certain perk relationship to that water. So, obviously, if you're in an area where water doesn't perk very well, it may be something to consider having a larger seepage pit or something like that. So those are things to consider and keep in mind. I appreciate that viewpoint.
Yep. So yeah, let's oh man, Steve, you're just racking in the questions now, aren't you? Um, so I don't actually remember if this was discussed, maybe a little bit with the plastic types, but what about chlorine? Was that kind of covered in some of those previous ones?
So chlorine as in
I would assume
damage
just
to the
treated,
filter?
yeah, treated
Okay.
water for that, and how does it handle for the filters?
Propylene is pretty solid for that, and that's why we are really specific on having stainless steel screens so that you don't run into corrosion issues. The steel housing filters have a little bit more challenge with that, obviously, because you're going to gain a little bit more corrosive material with chlorine because of the sodium and things like that. So those are things to consider. We didn't talk about it. Oh, he just posted on the rubber seals. Yeah, usually the rubber seals aren't as exposed to that because they're external to that, if that makes sense. The water's not flowing right up against those only, but on certain parts. But it is something to consider when you're designing for long-term maintenance. We tell people that that's why I say every year it should be addressed and checked. Even though, you can't set and forget anything. I'm sorry, that's not the way the world works. We do have some required maintenance. So even on the fully automatic filters, I would say they have to be checked at least annually, if not biannually, so that we can see and make sure those things are functioning and in good shape. And especially in chlorine situations, we may have to check them a little more frequently until we get a gauge of what that looks like.
Absolutely. Cool. Well, I think we're going to call it. Guys, have a wonderful weekend. And oh man, you know what? We do
Yeah.
have to answer this last question. This is a good one. Which irrigation controllers are also compatible with the automatic filters, or will they always require additional controller?
So that's a great question. They don't always require an additional controller. Here's the thing to consider when you're looking at keeping it on to the control that you have. Most irrigation timers are only an on-off switch. They're not going to determine based on pressure differentials. So you're going to be flushing maybe when the system doesn't need to be flushed, or maybe when it off of when it needs to be flushed based on just what you preset. So I would always recommend on your automatic filter to have the controller be part of that filter, because most manufacturers have that filter designed as a preset PSI differential that will read when that filter needs to be flushed and only flush when it needs to be flushed, or not flush when it doesn't need to flush, if that makes sense. The irrigation timer, is going to do its thing, but again, it's part of the package when it comes with an automatic filter. Usually most manufacturers sell them with their filter as part of their filter. So I would say it's best to probably stick with what's there instead of trying to divert from that, because you're going to get a better operating system than just what you're going to guess at in your settings.
Good enough. I say that's a great way to leave it. Guys,
Yep.
have a great weekend. Thank you very much. And see you guys next time.
Thank you very much.